First of all, what is a complete system? A complete system for the DNV 2000 is the controller itself. It will be delivered with a mouse. You have to add a camera and a camera cable, of course. You have to select the lens, what is suitable for your application and connectable to your camera. Then you need to have a light source, of course, if possible with dimmer, because then you can play around with the light itself. And you need a screen what you have to connect to the DNV 2000 that you can see what you are doing at that moment. In the standard package, if you order the DNV 2000, you find the controller. We have two different versions, one for 2 cameras, one for 4 cameras, and the mouse itself. Also included is a small SD card. Optional, of course, the camera. It's depending on which camera you want to use. 0.3, 2 megapixel, 4, 5 or 12 megapixel. The lens, the suitable lens for that type of camera, of course, because the lens for a 2 megapixel camera is different than for a 0.3 megapixel camera. And we can help you also with LED light and a power source for that light. That is depending on your application, what you want to do, of course. Therefore, you can use the type of light. These are the cameras what are available for the DNV 2000. That is 0.3, 2, 4, 5, 12 megapixel in grayscale, but also in color. Depending on the amount of pixels you have, the chip size and size, and also the pixel size is different for each type of camera. How to select the right components? It's also always depending on what you want to check and what kind of accuracy you want to have with your system. And finally, of course. And also, how many cameras do you want to use in your application? Because, of course, you cannot do everything with only one camera. Sometimes it's easier to use 2 cameras or 3 cameras. We have 2 types of controllers. One is with 2 camera connectable and one is with 4 cameras connectable. This is how our DNV 2000 system looks like. Of course, at the left upper corner, you have the power supply input, 24-volt power supply. Below that one, you have the I/O, the interface, the inputs and outputs. And below that one, you have the RS-232 connection. That is usable, for example, to connect the DNV 2000 to a PLC PC. In the middle, we have at the top the micro SD card slot. Below that one, we have an Ethernet connection possibility. There's also a possibility for PLC PC connection. Then we have the USB 2.0 connection. That is for the mouse itself. Below that one, it's the HDMI. There we can connect a screen, or you can use the VGA input at the bottom. And we have also there the RS-485 connection. RS-232, 485 and Ethernet outputs are usable for PC or PLC connection. At the right side, you have the connection possibility for the camera with the camera link cables. On the picture, you see the possibility for connecting 4 cameras. If you have only the one with the 2 cameras, then only the top slot is available. At the side, at point 14, there there's always the battery available. After 5-6 years, you have to replace it with another one. And slot 15 is not used at this moment, but that will be for the future to expand to other controllers. In numbers, of course, all the inputs and outputs, what I just explained, what are available on the front. General specifications, 24 volt, operation voltage between 90 and 110%. That means 10% above and below 24 volt. Power consumption is, of course, depending on the amount of cameras what you have connected to the system. Operating temperature is maximum 45 degrees Celsius. And the battery lifespan is roughly 5 years or more. It's not exactly to say, of course. Type of cameras that can be connected is only the camera what we can provide for the DNV2000 system. It's a camera based on camera link. You cannot use another camera with camera link because we have made special connections to the camera for that one. And we have color and grayscale cameras. The different types of resolutions, as already explained. 2 types of controller systems. The normal lens mount is C-mount. Only for the 12 megapixel camera we have F-mount camera lenses. Internally, we have the possibility to save more than 1,000 programs. With the memory card, depending on the size of the memory card, the SD card, you can go up to 9,999. So possibilities, projects enough. We have different types of region of interest, of course, rectangular, circle, polygon, ellipse, circle, arc, rotation, angle. I will explain that later. We have also different types of masks. I will also explain what a mask is and what you can do with that. And you have the possibility for 8 different types of masks in each window. Pre-processing, different types of pre-processing. We'll also explain where you can use it and how you can use it and when you have to use it sometimes. And you can switch in run mode, but also in edit mode. Calculation processing, there's also a possibility to add a complete calculation inside. We will not do that today, but I will show you where it is and how the screen looks like. We can only connect one type of display that has a full HD display 9020 at 1080, and you can connect via VGA or HDMI. Memory card is the micro SD card, is delivered with the controller, and we can only connect directly with the mouse, what is delivered with the controller. Okay, the second thing, we have now checked what kind of controller we want to have. We have 2 possibilities for connecting 2 cameras or 4 cameras. The next step is, of course, what kind of camera I want to use, what kind of accuracy I need to have. This is depending on what you want to do. If you want to do measuring, then you need, of course, a higher accuracy than only when you want to check on availability of some items or the position of some items. So depending on what you want to do, you have to calculate, of course, also your accuracy, but you have to use a different type of camera. So the third thing what you have to check, of course, how large is my field of view? What kind of items I want to check, and this has influence on the accuracy, of course, and also on the type of lens. The third thing what is important is the working distance. That means the distance between the camera and your object itself. That is the third item what has influence on the accuracy. Here you see a small overview how to calculate with the formula. In this example, we use a 0.3 megapixel camera. That is a 1/3 inch camera and has the amount of pixels, horizontal 640, vertical 480, and a pixel size of 7.4 micrometer. If we use a lens with a focus distance of 8 millimeter and a working distance of 700 millimeter, then you can reach a field of view of 480 multiplied by 360 millimeter. If you fill that in your formula, then the field of view will get out of this one. And the small f accent is, of course, the focus, and the B is the size of the chip inside of the camera. Some examples how to calculate. Of course, when I have an SD card, for example, it has the size of vertical 32 millimeter, horizontal 24 millimeter. So when I want to do something on this card, my minimum field of view will be roughly 40 multiplied by 30 millimeter. At the size, at the edge of the lens, you have always distortion, so the field of view must be a little bit smaller than your view of your camera itself. In this case, we choose for a field of view of 100 multiplied by 50 millimeter. And we have a fixed working distance. That means my camera is on a fixed distance of 200 millimeter from my object. If I fill it in, then I can calculate directly what my focus of my lens has to be. So in this case, I have the value of 23.52. So the nearby focus lens is 25 in this case. So I have to use a lens of 25 millimeter to reach this field of view on this working distance. And if you calculate back with this 25 millimeter focus, then you get the exact field of view. The optical resolution, what you can reach in this case with a 2 megapixel camera, is of course the size 93.8 millimeter divided by 2048 pixels, because that is what you have horizontal with a 2 megapixel camera. That means your accuracy is 45.8 micrometer for each pixel. This is the optical resolution. In a real application, you cannot detect on 1 pixel. So the minimum what you can reach is 3 to 5 pixels accuracy. That means you have to multiply this minimum with 3. I do the same with, for example, a 2 megapixel camera and I use a focus lens with 35 millimeter, and I want to reach a field of view of 40 multiplied by 30 millimeter. So the question is, what is my working distance in that case? This chip size is 11.26 millimeter multiplied by 5.98 millimeter. The working distance is, in that case, you can calculate that as directly 170 millimeter. And with that one, you can reach a field of view of 56 multiplied by 30 millimeter. And your resolution is much higher. That has always to do with your size of your field of view. The bigger your field of view, the less accuracy you will have. If you don't want to calculate, in our user manual, we have already done some calculations for you. You see here in the left column the field of view, what you can reach with a lens with a 5 millimeter focus or 25 millimeter focus, and then you have directly the distance in millimeters. The R, what is mentioned here, sometimes there is also mentioned that you have to use a ring between the lens and the camera, and with that ring you can change your focus between your focus of your lens in that case. If you have, for example, here a ring of 2 millimeter, that means in combination with a focus lens of 12 millimeter, we have a distance of 40 millimeter. 40 millimeter is not a standard in the lens, so that's the reason they can use rings in that case. How to build a vision project. I want to show you it with my demo unit. This is the demo unit what I use at this moment. It is on the fixed distance. You see here a small ring light. It is a LED light, white. I use a camera of, I think it is 35 millimeter focus, and I use a 2 megapixel camera grayscale in this case. At the right side, not on the picture, you see there is my screen, and that I will show you with my camera at this case. So now I'm going to switch over to the other camera. And then you see the screen, the startup screen, what you always see when you start up the DNV 2000 in that case. At the top, you see here the current project. I have named it Test 2. If you click on it with the mouse what is delivered with the controller, of course, you see an overview of the project, what is already in the controller at this moment, or on the SD card, because in this case I have added an SD card, so I can add a new project on the SD card, or I can put it directly in the memory of the controller. I always prefer to do that on an SD card, because then you can also easy put it on the laptop, for example, to save your program at the end. You can add a new one. You can give it a name. You still have to use your mouse. It's not possible to connect a keyboard to it. And you can give it any name what you want to have. It gives you an ID. You can have, if you have connected 2 cameras, for example, then you can also have 2 parallel flows in this case. And you can select if you want to have it on an SD card or in the memory of the controller itself. The NAND is the memory in the controller. I put it on the SD card. And then you see here below, in red, the new project. And also on the screen, automatically you see the project, the current project. That means the new one you have added is the new project what you have there. You can also delete, of course, from the SD card. You can copy a project if you want to use more or less the same project in another project. You copy it with another name and you can use it. You can change something, of course. You can also rename it, and with switch, you can switch over from one to another. Now I'm back in test 2, for example. You see that here at the top, automatically switching. The next button is the tool. You have a lot of things what you can do here. You can edit screen, for example, but the most important is the judge setting. On the screen you can have okay, not okay. At this moment, of course, there is nothing inside, but you can connect directly to an output 1 or 2, for example, and you can use the outputs, 8 outputs, you can directly connect to your program itself. And of course, you can also set up in your flow in detail. Finally, of course, when you have made the program, okay or not okay, directly on the screen to your request, what you want to have. I do everything only with a mouse, nothing else. The next button is the system. Here you have the control settings of the...
David, can I interrupt you for a minute, please?
Yes.
Sorry, but I still see your PowerPoint presentation. I can't see your camera, or what should we see now?
Then you have to, if I'm right, you see my camera and you see the PowerPoint, so you have to switch over from the PowerPoint to the camera. You see both.
I can't see that. I use web, this meeting chart. I don't install it. Where to switch? There is no any option. Web version. Maybe that is the problem. I can install it. So I will try. Yes, I'll do that. I think that is the problem. Sorry for interruption.
No problem. In system, you have the controller setting. The general information, of course, is the time and date. You see, I'm not updated it. You can choose the language in English or Chinese. I prefer English. My Chinese is not so good. And here you can also add where you want to start when your system starts up. I always want to start in the setup mode. But of course, when your program is running in your application, and at the end of the day, you switch it off, and in the morning you want to switch it on, you can start directly, of course, in the run mode. And it's also possible to restart your program. Sometimes it can be helpful. Camera setting, you have to connect always at minimum 1 camera, of course. You can do the individual setting here, but you see in the flow chart, you see also that you have the camera 1 set up. I normally set it up here, but basically it's the same menu what you are getting in. For the communication, you have the device setting. That means you can set your I/O. You can put your triggering at the input. You can also change this one, for example, to different triggers. Can you please switch off your camera? Thank you. So there are a lot of possibilities. This is just for setting up the I/O on the controller itself. You can enable it or you can disable it. The next one is the Ethernet, of course. You can set the IP addresses and the masks and so on. For the communication 232, you can set the bit, stop bit, and the parity. And the 485 also, of course. And if you are using communication, you can also set here the protocol for the Ethernet and the 485.232. It's depending on what protocol you want to use, of course. There are different possibilities. We will not do that today. You can find this in the user manual itself. Display settings, there are not so much things what you can do, of course. The screen resolution is fixed. We have only one possibility. You can add a ruler. You see it here at the top, but you can also switch it off if you want. And as the information at this moment is switched off. System info. Here you find the firmware versions, what is available in the controller itself. If you have a question, a problem, I always ask which firmware version is in the controller itself. And then I ask to send me a picture of these 3 numbers because that is most important. And the last button, of course, sometimes you can also update the firmware itself, and you can do that with the SD card. There we have to put on the new firmware, for example, and then you can do the full update. Then we have here, this is for zoom in, zoom out. Now we have the original size of this one, but you can also zoom it in, zoom it out, or in auto mode, of course. Now we are in edit mode because I want to make a program itself. But at the end, I will switch over to the run mode and then you can directly see what is happening. When you have a new program, it will always start with this flowchart. That means we have a camera. If you have only connected one camera, we have only one flowchart. If you have connected 2, 3, or 4, then we have here more flowcharts, and each camera can have its own flowchart. You cannot mix the flowcharts. You cannot switch from one to another in that case. What you can add, of course, we have function blocks inside of the firmware, and we can add more than one function block in one flowchart. You can 5, 6, 10, depending on what you want to do, of course. If you add more function blocks, the slower the system will be at the end, of course. First of all, you have to set up your camera. When you connect, when you have connected the camera itself to the controller, and when you have a new program, it is always coming up with this screen. That means the shutter speed is user defined. And in this case, you have already recognized the camera itself, but you can also use a reference setting, system setting. But the system will automatically see what kind of camera is connected to the system. You have to set up your shutter speed. Normally, I start roughly in the neighborhood of 60 milliseconds. And then you see directly what's happening below my camera. Because if I now go under the camera with my hand, you don't see anything changing. That has to do with this button. Now I'm in live update, and then you see my fingers, my hand, what's happening there. You can also use the trigger button in this case. And you can switch over to run mode. White balance. It's only used with a color camera. And because a color camera, you see all the different types of colors, and you have to calibrate your controller to the white. If you have a real white flag somewhere in, you have to put it in the view of the camera, and then you can calibrate your camera colors in the system. But in this case, I have a grayscale camera, so I cannot do that. The arrow Y, if I have a standard fixed working distance with a certain lens, I have already a region of interest, what is automatically coming up. If that is too big, for example, I can also change that. Just drag the corners to the size what you want to have, for example, this one. And then it will be only this part in the rectangle what will be used. So if I go back to my camera setup, it is only this part what will be used. In this case, I will only use the whole region of interest. Trigger setup, I can, and because I have the possibility in this case always to connect 4 triggers, I have only 2 cameras what I can connect to this controller, but I can still use 4 triggers in this case. And you can, but I have only 1 flowchart because I have only connected 1 camera. If I connect 4 cameras, I have 4 flowcharts, and then you can switch between the triggers. In this case, I use an internal trigger because that's more efficient for demonstration than using an external trigger. Flash setting. Flash setting, this is with this you have the controller inside for using the flashlight itself. Flashlight is normally used with high-speed applications because if you don't use that, you always see your object moving below your camera, and that is not what you want. And then you use flashlight. The flashlight is only active, the light is only active when your object is below your camera. So you can set up your the output. It's just an output what you do, and it can be connected to the controller of your light supply. Then you can give in the during time that it must be on, and you can also give then the starting time, how many milliseconds you have to start before your item is on the camera itself. Of course, most of the time the flash action will be before the active before your product will arrive and not afterwards. And you can, of course, enable and disable it. This controller is using always a a reference of your product to see if it is that it can compare the next product with the original one. So we are always comparing with the product itself. And for calibration, this is only usable when you connect a robot to it, and you can convert the data, the camera data in pixel to the millimeters or micrometers of the robot itself. But we have also other functions for that one, what is more easy to do than this one. Okay, I will do a simple test. I put here, of course, I do a live update. And I put a cap below the camera. You have to adjust, of course, the lens a little bit so that we have a clear picture. If you want to zoom in, you can use the zoom button, of course. And then you see that your object is getting bigger and bigger. And then you still can adjust a little bit to make it more clear. And you can go out back or set it on auto, then you see it completely again. I want to make a reference in this case, so I register my product. I can give it a name because that's easy when you have more products inside your flowchart, of course. It's also possible. For each function, you can use a different type of product. You give it a name, then you can find it back easy. Otherwise, you have only a number. And an ID number says nothing to say. So a name says more than only a number. Don't forget to save, because that's the most important, of course. Okay, I have set up my camera. You see here in the corner, you see a button. If I don't have set up the system right, you will get here an orange button at the end, or when there's something wrong, you get a red one. The result of the output is for the communication or the I/O directly. It's always there. And also the status that is for on the screen is always there. If you want to add a function, inspection, you go to add. And of course, there are a lot of inspections already there. You see, for example, an area, blob, stain, edge, and so on. These two grays are not available in the firmware at this moment. One pole position is used for connecting to a robot. And in that one, you can easily set up the robot itself. I will show you how it looks like, but I don't have a robot connected, so for me it's difficult to do, but I can show you how you can set it up in that case. What I want to show you today is I want to show you the area function, the blob function, shape function, the 2D barcode function. I want to use also the edge angle function. I can show you the edge count function or the edge pitch function. It's basically quite simple in that case. So that is more or less the idea for today. I want to start with the blob function. It will be always after the block in green in your flowchart. You see here the orange light. That means it is not right set up or totally not set up. So I have to set it up in this case. A blob function, blob means you check on a cluttered amount of black or white pixels itself, and you only count more or less the size of it. The blob function gives you also the coordinates of the blob itself. That means for this cap, for example, it's black. It's quite easy. I have a lot of black pixels in that case, and I have automatically the coordinates of the middle of this blob. Okay, I have to select. This is, if I open a function block, I always see at the left side the same functions what I can or have to set up. It is not always necessary to set up everything, of course, but the most important is, of course, the image. You have to select your image, the region of interest. Parameters is necessary, and the rest is optional. In this case, I have only one picture, so that's quite easy. I select that one. My region of interest, in this case, it is complete, the complete size of my region of interest of the camera, because I want to show you the difference if I use, for example, 2 blobs or 1 blob. Now I have not completely the complete size, but when I use this button, for example, then I have automatically the full size of the camera. And with this one, you can go back to the beginning. Because blob means I can check on white, only on white and black pixels, I have to do pre-processing. I see a lot of gray here and also some light. I want to change that into black and white. That means I can use a filter. In this case, I need to use a binary filter. That means with the binary filter, I change all the gray into black and white. But you see also a lot of other types of filters what we can use in combination with our application in that case. But for blob function, also for area function, you have to use the binary function. Then you can see also the overview of the intensity. You see that my cap is removed. It is changed. And when I move it to the right, I see automatically everything is changing to black and white. And depending how far I go, in that case, you see that it is removing all the gray into black. The last letters are white, so I cannot remove that one. If I want to do that, then I have to change my camera setup in the beginning, and I have to change the shutter speed to a lower level or a higher level, and then we can go up to complete black if I want. But in this case, I will go more or less to the middle. This is a blob, and half of it is white in this case. Because I have a lot of different pixels, different types of sizes of blobs, and every cross, yellow cross, is a blob what we see. So I have to give the size of the blob what I want to have finally. And if I want to see, for example, only one, I must make my lower much higher. Then I see only one cross, and that means I have only one blob. In this case, you don't have to set so much, depending, of course, what you want to see. I want to see the black object and not a white object. The only difference is that the cross is moving now, in this case. When you have a complete black object, of course, then the cross will be exactly in the middle. If I want to detect on the amount of blobs, I can set the limits, of course. Now I'm detecting the amount of blobs between 0 and 9,999. So that's pretty much. But I can change that also into 2 or only 1, for example. If I have now 2 blobs in the view, it will give automatically an alarm. Location, I'm not using this in the blob function. I will show you when you use it. That will be in combination with another functionality. And execute, it's always or never. Yeah, never. I don't use that in this case, but sometimes it's easy to do that. You can use a function block to check something, but not execute it on the screen. But in this case, I will execute it always. Here below, you see automatically the result. He has found 1 blob. The center of the blob has this coordinate and the X and the Y. So that is my center of the blob in that case. And the blob has a size of 352,338 pixels. So all information of that blob you see directly below. And of course, it can be useful to have that information available. It's depending on what you want to check, of course. Don't forget to save, because that is important. And now I have already done 1 check, for example. The result, I can give the output in detail. Then I have to check the item, for example, of my blob. I can give out the number of blob, but I can also give out my X and my Y coordinate of the first blob. Here you see automatically the registers in the system where the information is put. And you have to choose, of course, when you want to go communicate with an external device, you have to choose how you want to go out. For example, 485. And then you have to save it, of course. This I only set up once, no more, because I don't want to use it in this demonstration anymore. But if you want to use it in combination with your PLC or PC device, then you have to set up this, of course, every time for the item you want to see in your PLC program. For me, it's more important the status, because the status will be on the screen. I have the same setup here. I can show you the amount of blobs. I can show you the X coordinate and the Y coordinate, for example. Now I have set up 1 program. I can go directly to run. I see here on the screen my cap. I have found 1 blob. This is live information. But of course, I can also show you the item list. And here you see my limit setup. I set the upper limit to 1 and the lowest to 0. That means if it is between 0 and 1, the output is okay. When I add a second one, for example, that must be at that side, then you see he has found 2 blobs. This one is much wider, but in this case he sees that still. But it is not okay because I have mentioned that my upper limit is only 1. So that can be, this is not possible. I can show you only the coordinates of the first one. That is the X and the Y coordinate. When I move this one a little bit, for example, then you see also the X and the Y coordinate changing. Here you see also the speed. The interval time is 24 milliseconds. That's only for checking. Okay, that is the blob function. I remove this one. You see automatically that these two are not right set up because in this output is automatically the blob function mentioned. So I have to remove also these details. And I can do that here. First select, of course. So now it's clean again. I want to show you the difference for the next function. And the next function will be the shape function. I put it, the cap, the other way around in my view. And there you see the inner circles on the screen. That is inside the cap itself. Because my picture is changed, I make a new image. I can give it a name. One letter for me is, in this case, it's not important, of course, but. And I save this picture. Then I add the inspection, the shape function. And you see the orange button is there again. I open the shape function and you see at the left side, you see the same functions as with the blob function. First, I have to select my image. Then my region of interest. In this case, I also want to have the total, of course. So I have total corners. I don't use pre-processing because I want to see the difference in shape in this case. So I only set up the parameters. Now you see a lot more parameters in this case. First, I have to create the model of my item. In this case, it's round. So my region of my item is not rectangular, but a circle, for example. I can just drag it around my cap, make it a little bit bigger. And then I add, okay. You see a lot of red items coming up here, and that are the checking points for the shape itself. You see that only a few. Automatically, you see here the number of shapes. It's 1, of course, in the view, and the coordinates where the shapes is in at this moment. The X coordinate and the Y coordinate. Angle is important when it is not a round one, because it's depending on your object. It's important to set this up to 180 degrees, because then you can turn your object 180 degrees left and 180 degrees right. Because now we have a round cap, that is less important. But when it is a square or a triangle or whatever, it is important to have that, otherwise it will give an alarm when it is rotated in your view. I can also check if I want to search for only one or, for example, two items in my view. So I can count with this shape function. If I have, for example, a rectangular item and a round item on one conveyor belt, and you make your shape function only for the round one, it gives you only the coordinates for the round one. So it's easy for a robot to pick up these items from the conveyor belt, for example. So you can select with several robots several items from one conveyor belt. In this case, I only search for two, but you can go up to 999. I always have, for picking up the middle of the shape itself, if you have a triangle, then you can have a different weight, of course. At a point, if you have a small point, then the weight is not always exactly in the middle. So you can enable your rotation center, and then you can change your X and your Y coordinate. Now it is, so then you can change the middle, your heavy point, you can change from that one. This is, for example, 6, and it is 20, I don't know. Then your middle point is changed. This one is round, so you cannot see it, of course. Then you have to take a square one, and then we can see it. Limits, more or less the same as with the blob. You can go up with the number of shapes to 9,999. But what you can also do is you can, if it is not always in the same position, you can give here the lower and the upper limit of your coordinates. And when it is not on that place, it gives automatically an alarm. What you also can do is checking on similarity. And in this case, it's 99% of the shape is the same as the original. And I set my angle between 180 and 80. 180, that means I have a full round where I can check on in this case. Location I don't use, because I give automatically the coordinates out, so I can have always the position of my cap. I will not set up the result output, because that is only for communication. I only want to show you the details screen. For the shape, I want to show you the number of shapes. And I also want to show you the similarity. And then I go back to run to the item list. You see automatically that the similarity is a little bit lower. My light is not so good at this moment, so it is not completely Good. Now it's better. If I add now another cap in the other way, for example, he sees still one cap because this one is the other way around, and the shape is completely different because the inner is completely different. If I take a cap from the same inner, and then I should have, of course, he has to count to 2. You see it here. It will not show you the shape of the similarity of the second one. If I want to have also the similarity of the second one, I have to set it up in the status, of course. Because I have added in my setup that I can have 2 items in the view. So you see here that the first one, the left one on the screen, has a similarity of 97, and the second one has a similarity of 66, because you see here more white at the ring, so it's a little bit different than this one. If you have set your lower limit, for example, to 60% or to 70%, this one will be not seen, and only this one will be picked up. This is the shape function. So I remove this one. Now I use another device. For example, this one. An SD card. It's always nice to have that one in the view. Okay. A new item, so I have to register also this one. The new function, inspection. And for example, yeah, we can do edge counting in this case. The orange light, so I have to set it up first. The same items at the left side. Select the image, region of interest. It's depending on what I want to do. I want to find the edges, the left and the right edge. So for me, it's rectangular. It's enough. And then I can make it a little bit bigger. And the rest is not important for me. Of the view. Pre-processing is depending on, of course, what you want to do, but in this case, it's quite easy. If you make it binary, because my SD card is black, I see here the intensity of my picture, and if I put it there, you see directly what's happening. And I want only have clear outside edges in this case, because that is what I want to see. The more I go to the right, it is more clear, of course. If I only want to find the left and the right edge, I have to do something in the middle, because, yeah, of course, you can see these letters have also edges, and that is not what I want to do. So I can go back to my region of interest. That means my region of interest is not the complete SD card in this case, but only the outside. So I can put a mask there. In this case, a rectangular mask. And I put that mask over my letters because I only want to see the edges and not in the middle. So now I have put here a mask. That means in the inside of the mask is not used in this application, this function block. So I see directly also the number of edges in my object. If I go back to pre-processing, for example, then you see still this in the original. That means it is not used in this function, and I only check on the outside edges in this case. Then I have to set up the parameters. I can check from left to right. I can also check from up to down or from down to up. At the left side, you see here directly the edges, what he is seeing. I want to have it from right to left. Here at the bottom, you see my level. Of course, I don't want to see this edge because I'm only interested in this edge. And also I don't want to see this edge in that case. So I can check only for too light, too dark, for example. Then I see only the outside edges. From the right, I'm looking from the right to the left. I'm going from white to black. That means I have this edge. And then I'm going from, this is also white to dark. And that means this is the second edge, what he is finding. I have two edges. Of course, I can change that also to 1. And then he gives you automatically an alarm because he is already finding 2 edges. Location I don't use at this moment, but I will explain what's happening at the end when I don't use this. And I'm only setting up the status in this case. I can, in edge count function, I can only check on the number of edges, and I can check if the number of edges is okay or not. I want to show you only the number of edges because if I go now back to run, I see automatically he is finding 2 edges, no more. If I make more edges at this moment, I can do that, for example, at this moment with a screwdriver. Hopefully you will see it. Not at this moment. He's changing now. You see that he's changing now the edges. What also is happening now, because I'm moving the SD card, you see he can not find the second edge anymore. And that has to do, I have set my function only on the place, on the position of my SD card at that point. So if I want to follow my function, my edge function to the object itself, I have to use also a shape function. Oh, that is a setup. Because then I can find my shape first. My region of interest is, of course, the complete field in this case. I only have to set up my SD card as a rectangle. And for the rest, it's okay. He sees a lot red. We find the shape automatically. Don't forget the save. Now in the edge count function, I will follow my shape. So in this case, my X position, I will follow the X position of my shape and also the Y. And the angle. And when I go back now to run, he shall follow the SD card. It's outside, that doesn't work. Now outside my, you see them outside of my window. Then I have to change that also in the edge count, of course, because now my region of interest is changing. It's not only that rectangle anymore, but the complete view. He's finding a lot more edges than I want. And that has to do with the letters on the shape itself. Okay. Next function. I put it a little bit, change the direction. I make a new photo of it. This one I remove. This one I remove. And now I'm adding edge angle function. This is my image. Region of interest. Rectangular. What I want to do, I want to find the angle of my edge. What this function is doing, he will look at in this area to the edge, and also in this area to the edge, and he will take the coordinate from the middle of that area and also here, and he calculates the angle of the edge itself. Because I want to have a clear edge, I make it binary. It's quite easy. And then I have a very clear edge in this case. I go from left to right, and then I see automatically here the angle, what he is calculating. I'm going from light to dark in this case. This is the point in the middle of this area, and this is the point in the middle of this area. You see here also a small one, that is this letter, but that is not what I want to see. So I can play with the limit itself and also the strength. You can make it bigger or lower. In this case, if you make it 60, for example, then the green line will go up. So if you have some distortion in your object, then you can play with these items. And also smoothing, now it's 3. That means you have a very wide one. But if you go back to 1, for example, then you see the smaller items also. But that is, of course, that's difficult. This is not what you want to see, so you can better make it a little bit more smoothy. And then you have only one peak. And also you can change your lower limit. Here we have also a lower limit. It's now 5. You can make it higher to make it visible, I guess. Yeah, it's difficult to see here in the dark, but it will go up the level itself. The angle of this one is 109 degrees. These X and Y coordinates are the middle of these areas where he has found the point of the edge. Also you can give this out on the screen. This one I will remove. I can show you the items itself, and I can give you the angle on the screen. So it's depending on what you want to do, of course. It's depending on what you want to see. In the item list, you see directly the angle. If I turn it now a little bit, you see the angle is changing. Okay, next function. This one I will delete. Then I have the camera setup. You don't see my changing my screen, but I still have changed, of course. And now at the back side, I want to see more clear all the items. Because now it is getting important, of course. So you see I'm adjusting the lens, and by doing that you see a lot of things changing, and it is more visible in this case. I register this one also. I add an inspection. For example, I want to count the amount of edges. My region of interest is only a small part of the SD card. To make it even more to black and white, you can also binary that one. And then you see also here, it's getting in the middle, more dark. So it's better to detect. I want to go from left to right. In this case, I see all the edges. That means from dark to white and white to dark. So I see the left and the right, but I can also only see from dark to light, for example. Then I have the half of the edges. And if my signal is not so good as this one, you can also higher or lower, for example, the level. And then you see the green line moving. And you can also change the smoothing, for example. That means your edge will be bigger. But in this case, the signal is good, so why should I do that? Directly, I see the number of edges, what he's detecting, below, of course. If you want, you can set also the limits. So if you want to check if everything is there on your item, I can always check. It must be 9, so when it is lower of higher than 9, it's not okay, but when it's lower than 9, it's also not okay. So you can make the lower item to 9 and also the upper to 9. And now I want to show that also on the screen. I want to see the number of edges. This one I have to remove. That's the red one from the last time. And now I'm going back to run. Automatically, you see here the green button. It's okay now because I have still the 9 edges. If I add a screwdriver to it, you see the amount of edges is changing, and it is not okay anymore because I don't count 9 edges at this moment. So that's your detecting point. If I want, I can also add here a second function. because I can also calculate directly the edge pitch. Edge pitch is the middle of each between two edges. I select the same one. My region of interest is also rectangular in this case because I want to see all this, basically the same edges. Also here I do pre-processing binary because then I have a very clear edge here, and that is important. For the parameter setup, I go from left to right. You see automatically here below the edges, and here at the top you see the pitch, the middle of between two edges. You can also you can count with it. So if you don't have enough edges, for example, or your pitch is getting bigger every time, it's also possible to detect, of course. I also want to see this on the screen. I want to see the count, and I want to see, for example, the max pitch and the minimum pitch. So basically, I'm always doing the same steps every time. Here you see the amount of pitches and also the maximum pitch and the minimum pitch. And if I add now a screwdriver to it, you see that the value is, the amount of pitches is not good enough anymore. I didn't set the maximum pitch or the minimum pitch, what is acceptable, but you see the value is changing. And the speed is very high, of course, for this function. Okay, that was edge count and edge pitch. Now I go back to a new one. That is, for example, barcode reading. I can change my region of interest if I want. I'm only interested on this part of the car. So then you see only that part. I make it a little bit clear. I make a new register. Will be from barcode. Camera setup. Inspection 2D barcode, because we had now 2D, but also the 1D is of course available. You have to set it up. The image. My region of interest is the whole view, because I don't know where it is, of course. Pre-processing, you can do that. It is not necessary, but you can do that. Then it makes it more black and white, more visible. And automatically he sees the string. It is here also below. And he had not more, the length is not large enough. Can make that larger. But he will detect it automatically, but he will not display it here on the screen. If I only want to see this barcode, for example, you can set also the string here, then you have automatically okay or not okay on the screen if you want. But I don't, I only want to read it. So in this case, I want to see the string content. Of course, the red ones I have to delete because that is not okay. On the earlier one. Here you see already the string, also here. You find automatically the item. And at the top, you see the complete string what he's reading. So you can read quite easy with this camera. You can quite easily read the barcode. You can also turn it. Of course, the barcode must be in the view, otherwise it will not be detectable. But it can be rotated, doesn't matter. Now I go back to my square again. So this is what I'm seeing, still the same. The next thing I want to show is, for example, OCV, character reading. The same, every time the same steps, what I have to do. The image, the region of interest, rectangular. I want to read my characters in this place. For example, IAC. Because the letters are not completely clear, but gray, can be difficult to read. So I do pre-processing again, binary. Then I have a very clear picture. Parameter setup. You see automatically here the information from the letter itself. He reads 3 letters in this case. You can see here the characters, but he don't see what letters there are at this moment. That's logical because this information is not connected to any letter at this moment. So you can connect that directly to a dictionary. In this case, it is only string 1 where I have the 3 letters. And I have to add that information. And you see automatically he is reading the 3 letters. You can, in this case also, you can make a complete dictionary from your own if you want. You can see all the characters and register all information here. So you can read more than only 3 letters, of course. If you want to have directly okay or not okay, then you can mention here the string. Now he's reading AJAC. If I mention here something else, then I get automatically okay or not okay on the screen. But this at this moment not interesting for me. I set up also my information here. I want to see the number of characters, but I will want to see also position similarity, but I want to see the string, the text, what is really there. You see that he is reading sometimes already something else, because in the string is added ABC. So that means it is not okay. So if I want to change that, I have to go back. Go back to my limits, because here was mentioned ABC, and I have to clear it. So now my lower limit is blank. So now it is okay again. You see that it is changing every time. That means my light is not good enough to read these kind of characters. I have only standard LED light, but you must have for this kind of applications more diffused light, so that you have not more an homogeneous light on your object itself, and then you can read it more better. Okay. Yes, then I go delete this one. I only want to show you what will happen with the one pole position. I will show you back to my SD card, of course. First of all, my region of interest has to go back to complete overview. That's on top. It's better to read, of course. I just want to show you two functions. Okay. So this is the camera setup. Then I register also this one. I don't know if I have it already. It's there. Now I add the function one pole position. And with this one, I can learn the camera, the coordinates of my robot, for example. I will go for a 4-point learning because that is more easy. Of course, I have to set up a shape. It's always in combination with the shape. I have to set up the shape itself, the roll region where I want to find it, of course. In this case, I don't pre-process. I only set up the shape itself. He's learning. He has found item itself. He learns it. Okay, I have set up my shape now. You see, it is not ready. The CCM is not ready. Now I open that view, and I have now I see here the points of my view. So that is this one. I can drag it to points in my view, and when I want to set up the robot itself, I make in the view for points itself, of course. And now I do it very quick, but you can do that. More. These are the 4 points here at the left side. And then you have just to fill in the coordinates of your robot. That means the camera is going from this point and then up. But the robot is coming from this point. That means you have to swap. And this point is, for example, 0, 0, and then 120. That's this point. Next point. 200, for example. 120. So you can give directly the coordinates from your robot. And the P3, that's that point. And this one is 0, 0. And then you can automatically learn. That means these items, these coordinates, are now available in the system. Be aware, the camera is giving only pixels out, and the robot needs, of course, coordinates. So this one is now set up, and you can give it out automatically with 232 to your robot itself. So that is the function one pole position, what can be used in combination with a robot. And the last function I want to show is the area function. Every time the same, set up the image region of interest. I can make an, of course, you see here the different forms what were available. And of course, the most of the time you use rectangle or a circle, but you can make also an arc for if you want, half round. You see here the shape, or an ellipse. Polygon. Then you can just drag your points where you want to go. You see you have a lot more points, of course, in that case with the polygon. And you can make the shape exactly like you want to have. But in this case, I only want to show you the area function. I take simply a rectangular. Area function, you only check on black and white pixels. This is the area for me what is interested. If this item is coming in the view of my camera, I only want to see if this picture is there, the arrow with the lock. Area function, you have to use the binary function because you have only to check on the black and white, the same as the blob function. And the further you go to the right, you see that it is getting more clear. In the parameters, you don't have to set up anything. You can set up the upper order limit, but you can also drag it here. That's the same. But I don't want to have the mix between the gray limits. And with the limits, you see that it is calculated the amount of white pixels in this case. And this is the total what can be reached with this kind of camera. And if I check now, for example, what shall I do? 1500 as a lower limit and 3500 as an upper limit. Just set up the status detail, the area function. In the item list, the total area. Remove the red ones. Don't forget to save. And now I can go back to my item list. You see directly, this is the value what he's measuring. I have set an upper limit and a lower limit. Now it's okay. When I use a screwdriver on that item, you see that my value is changing. And it's coming below the lower limit. So that means it is not okay. With this, you can easily check if some text is there or not, and it is not interested what kind of text is there, but you see that it is there or not. Okay, with this, I want to end my workshop for today. I don't know if there are any questions. Nobody has a question? Then I want to close this meeting if nobody has a question. You can always reach me by email if you have a special question about this software, of course. The DNV 1000 and the 3000 are similar units, and also the most of the items what you have seen today are also in that kind of firmware available. Only the layout on the screen is of course different. The VGR software what we have, Dia Vision VGR software, is also similar, only that is PC software. So you have to add in your application an industrial PC where you can run on that software in that case. If there are no questions, I want to stop sharing my screen.